Hello, today we're going to be looking at another Leetcode problem. This is problem number 523, and it says that we have to find continuous subarrays of sum. There's a very specific requirement here. So let's understand the requirement first. So you've been given an integer array nums which has positive integers. It includes 0, and you have been given a target integer k which is positive. Now you have to identify if this integer array nums has any good subarray. Now the definition of good subarray is that the subarray should be of length greater than or equal to 2, and the sum of the elements should be multiples of k. Now, if we look back at some of the subarray problems that we saw, let's quickly take a recap, right? So we looked at positive integer subarray problem where we were able to use rolling window and we were dynamically able to shrink and expand. So this would be shrink operation and this would be expand operation. We were able to do that, and we were able to dynamically identify the subarrays that satisfied some condition like sum greater than or equal to the target. We also looked at another variation of the problem where we had positives and negative integers, which meant that we could not dynamically shrink this because the negatives would reduce the sum, and even if we have expanded the subarray, the overall sum would be misleading in terms of the next direction that we have to take. So in this case, we used the prefix sum approach where we computed the prefix sum and we tried to see if the current sum if for the current sum that we have calculated so far, and if we subtract the expected target, do we have a prefix that we have seen before? So that is a prefix sum approach that we took previously. Now here, if we look at the problem, what we are seeing is that we have been again given an integers array. Now this time we have been given only positive integer array, and so the expectation is that to find a subarray whose sum is a multiple of the target k. Now we might be tempted to think about the rolling window approach because these are like positive integers, but the challenge here is that the increasing and the shrinking, or the expanding and the shrinking operation of the subarray is not very straightforward. What I mean by that is, how can you tell if shrinking the subarray is going to take you to a smaller multiple, like for example, if k is equal to 6, how do we know that shrinking this would take you to a multiple of a smaller multiple of 6, or expanding would take you to some larger multiple of 6, like for example 12? How do we know that stuff, like whether I should increase it and go for a larger multiple or shrink it and go for a smaller multiple? It's not very straightforward, right? And so here again we are going to use the prefix sum approach, but there is a slight twist to that. So let's understand what that means. So if we look at what the problem looks like now, we have a subarray and the sum of this is equal to is a multiple of k, which means the sum modulus k is going to give me 0. Now I have a prefix here, and this is the sum of this prefix is certainly not equal to any multiple of k, and so when I take sum dot modulus of k, it's going to give me some remainder. And we know that this is the case because otherwise, if this was a multiple of k, this itself would have become a valid subarray. in our case. This is not, and so we're going to have a remainder here. Now, what we can see is that if I have a remainder coming from the prefix, and if I add a subarray of remainder 0, and I again get a remainder of r, that means I have basically discovered a subarray that is summing to a multiple of k. And that is how I'm able to get to the same remainder, right? So this is the approach that we're going to follow. And let's look at the pseudocode real quickly so that we can see that logic in action. So we're going to define a prefix here, just like before. And this time, what we're going to say is our first value is actually a remainder. And this occurs at which position? This occurs at -1 position. So if you had, going back to the same problem, if you had this subarray whose sum is equals to a multiple of k starting from 0, then we want to identify this, and so we want to say that the prefix with remainder, so this is going to have a prefix of remainder 0 exists, and this exists at minus position -1. Now, why are we taking an index value, and index value especially of -1? Now, two reasons. One thing is we have to also identify this length. Now, if we were not looking for subarrays of length greater than or equal to 2, then we could have just used the set and said that, okay, if I'm getting a remainder again, that means I have discovered a subarray. But if I have to identify the length as well, I need to preserve the location where I had seen the previous prefix. Okay. Now in this case it is -1 because this is to handle the starting case where the subarray of multiple k starts at the beginning of the given array. Now let's continue. So now let's start processing the element, start evaluating that equation, and see if we are able to find a good subarray or not. Okay, so in this case, since index is important for us, let's capture that. Okay, I missed to initialize the current sum, which is important because this is our default value because of the equation that we are trying to get to, right? Let's update the current sum. So now what I'm saying is that, remember what I said. If the prefix has a remainder of r and this has a remainder of 0, okay, and the overall remainder is again r, then if this remainder is not seen in before in the prefix, then update it, then we add it to the thing. So we will say that prefix of current sum modulus k. I have not seen this remainder before at this index, so I'm seeing it at present at this index. Next, if I have seen it before, then I want to make sure that the difference or the length of the subarray is greater than or equal to 2. So I will say index minus prefix of current sum modulus k is greater than or equal to 2, then you return true, otherwise we're going to be returning false. That's about it for this problem. The trick was in understanding how do we build this equation for the prefix sum with the current running sum variable. I hope you like this video. You can obviously implement it in your programming language of choice. Thank you. See you next time.